In this video, we're going to be taking a look at a technique and feature that is unique to MPLS or LDP specifically, where normally in we refer to IGP and LDP, where the router ID is an IGP is normally just an identifier, not normally a routed. It does not need to be a routed interface to where other routers should be able to reach that address. In LDP, that is the case. It needs to be routed, it needs to be reachable, because the router IDs are going to be what the MPLS LDP TCP sessions are formed off of. So it's important that that happens. What we can do in this case is to update the transport address. So basically what happens there is you can change the transport address to be an interface on a per link basis. So for instance, if you have a situation where you have, and I've only ran into this once, and it was more of a design situation where there was a firewall sitting between two MPLS routers. It wasn't actually a live production network, because I wouldn't normally do that. This was more of a, if you were given this scenario, and so I was like, okay, it was actually a CCD to study session that I sat in on, my point of view was you shouldn't put a firewall between two MPLS routers, regardless of the situation. But if you were to do that, or you had a situation where you had to update it, you could use the transport address update feature. So the LDP transport address is the router ID by default. So this feature is useful if a firewall and transparent or layer 2 mode sits between two label switch routers, because the way that this is going to work out is the LSRs are not going to have visibility to the remote the remote LSR loopbacks for the router IDs. So what you would do in iOS is you would go to the interface level and change the MPLS LDP discovery transport address to the interface of the local interface. An XR, you would do it underneath the specific interface that you want to modify. So if we were to do this, and this is going to be a pretty simple change, I'm not going to go into a whole lot of detail on it, but if we were to go look at this, if we were to do this on XR1 and router 1, go ahead and pull up secure CRT here real quick and bring this guy over here. On router 1, I can come in here and type in interface. If I type in do show MPLS, show MPLS LDP discovery, and enter, it's going to be using this interface as the LDP identifier. So if I was to go to interface gig 1.111 and type in MPLS LDP discovery, transport address is either the IP address or the interface. I could type in 10.1.11.1 and hit the enter key. And then on XR1, I would go over here to here, and and we actually just lost our adjacency. It flapped. So it should be, let's see here. So right now the adjacency is back up, so let's log in and do show MPLS LDP neighbors. I believe I can type in brief. Yes. So we should have an adjacency with router 1, and the peer is this guy, but on R1 it's show MPLS LDP discovery. We are using, it's still the interface here, because that's our local loopback. But if we go to XR1, go to global config and MPLS LDP and type in discovery, and we come in here, we type in actually no, I'm sorry, it's exit out. It's address family IPv4, and underneath here you would type in the discovery is going to be for the transport address is going to be 10.1.11.11, and you would hit the enter key there and commit that change. So it goes through and it forms an adjacency. It's back up now. So if we come back over here, we do a show MPLS LDP discovery brief. We are now, it still shows that router 1 is the local connection. Discovery, and we type in neighbors brief. We still have the neighbor set up to R1, but we just changed the discovery address. So show MPLS LDP discovery detail. Actually, let's go gig dot detail. My source address and my transport address are different. So on R1, it's the same thing. If we come down here and do a show MPLS discovery detail, we're going to see that we are using our transport address is, we'll notice here that the local address is the transport IP here for the connection to router 2 here is 172.16.1.1 and 172.16.1.2, where on the connection to XR1 it's 10.1.11.1 and 10.1.11.11. So we're using the connected link between XR1 and router 1 as our discovery interface and not the loopback, even though the LDP identifier, the router ID for LDP is still the loopback 0 of all the local router. That's fine. That doesn't change anything. It's the actual interface you're using to form the adjacency. That is what's changed. And that's what I wanted you guys to see. It's unique to MPLS, so that's why I figured it'd be useful to know that. And again, it's one of those things where in a knowing that that could be changed is important, but I don't actually have a legit use case. I've never seen it deployed in production, but it's one of those things where it's possible. That's why the configuration is there. Normally, you could, if you were to go to global config and type in MPLS LDP and do a question mark, just about every one of these options here is specific to something that had to be enabled because a given circumstance came up with a customer and a feature had to be enabled. So these are things that come into play when a customer needs something. They reach out to Cisco. Cisco creates a feature and then tests it, make sure it's going to work, not break anything or cause a bug, and then they deploy it. However long that period of time is unique to the situation. But I can only speculate that going back, if you went back 10 years ago, that you wouldn't have had as many LDP options as you do today. Now, if we were to do MPLS label, we have different label capabilities. So we have label protocol, we can use LDP, we have mode, we could specify per VRF and some stuff like that. We're going to take a look at that more or less when we actually get into MPLS VPN, actually doing the routing. Right now we're just focusing on the LDP portion of configuration, but that's basically how you could look at it for the most part. But until next time, guys, thank you so much for stopping by, and we'll catch you guys in the next video.